Hello, everybody. How are you doing? It's me, the Pioneers in Methods. Okay, with you again. First of all, I'm going to share the lecture for my audience, for my kids, for my colleagues also. Okay, share. Okay, okay, okay. Again, I'm going to go back. I thought that. Okay. Yes. Okay. Hello. How are you doing? It's me, Mourad Sultan Ezouidi, the mathematical teacher. Okay, the pioneers in methods, the Tunisian researcher in the field of solving problem to the power n. Okay, already let's say told that. Okay, outcome is here. This is the problem learner that I'm going to solve now. Is that this is the pioneers in methods. Mr. Mourad Sultan Ezouidi is now live on Facebook and YouTube and X in X space X and in Instagram. Okay. So this is learners, the equation that we told that we are going to solve. What is it exactly? I'm going to see it. Okay. So this one, yes. This the equation we told get ready to join your lecture and get rid of the usual method. Soon I will be live with you, my dear. Okay. This is the pioneers in methods, Mr. Mourad Sultan Ezouidi, and we are going to apply this theorem of Mr. Mourad Sultan Ezouidi so that we lead you to find out the exact value or the exact roots of this polynomial to the power 4. Okay. So here, learners, you can see that. Okay, you can see that our polynomial to the power 6 is going to be written as p of x equal x raised to the power 6 minus x raised to the power 5 plus 21 divided by 6 squared times x raised to the power 4 minus 44 divided by the cube of 6 times the cube of x plus 62 divided by 6 raised to the power 4. Okay, 4. Okay, this is 2, 3, 4. Okay, x raised to the power 2 minus 52 divided by 6 to the power 4 times x plus 24. Okay, 6 raised to the power 6 equals 1. Okay, where let's say this is 52 divided by 6 raised to the power 5. I'm just this with 5. And 62 divided by 6 raised to the power 4. This is okay, 6 to the power 4. Okay, this one. So now I'm going to do it now, learners. Prepare yourself, and it's an occasion for you to get to know about what exactly about learners uh, solving problem to the power 6. Okay, now I'm going to this is, of course, is going to be 4. This is 4 simply because the coefficient here is going to be 4. And this is 52 divided by 6 raised to the power 5. Okay, I will just write here 5. Therefore, this is, learners, our problem to the power 6. We are going to solve this one. Okay, I will come here, learners, step by step. Okay, like that. This is example 17 that we explained on my channel. Okay, of course, my channel consists of, let's say, a variety of degree of polynomials, not only 6, but there is also 7, 8, 4, 5, and so on. Okay, so this is, we told that this is it's a polynomial to the power 6. We want to find, learners, the roots of this polynomial. So we should determine the values of SR of ODQ. SR of ODQ is denoting, let's say, the new sixth degree polynomial equation that I would obtain for this from this original sixth polynomial equation. Okay, now you can see that R in fact belongs to the set of numbers from -1, 0, 2, 3, 4, and 5. 5 here in fact is 6 minus 1, okay, because the highest power is 6. Now you see the coefficient are respectively L0 of ODQ is 1, L1 of ODQ is 21 divided by 6 square, L2 of ODQ is 44 divided by 6 cubed, and L3 of ODQ is 62 divided by 6 raised to the power 4, and L4 is 52 divided by 6 raised to the power 5, and L5 is going to be 24 divided by 6 raised to the power 6. In this example, learners, you will get, let's say, roots, exact roots of this polynomial to the power 6, but the roots are all complex. Not, there is no real root here in this example. Okay, so let's focus on the theorem that I discovered. Okay, this theorem will help you learners to find the coefficient of your new sixth degree polynomial equation. This one. Okay, so now we are going to use the formula, the discriminant formula, discriminant, discriminant formula of Mr. Mourad Sultan Ezouidi, the Tunisian, the mathematical teacher, the pioneers in methods, is here now with you to let you understand the theory of mind and to let you practice this theorem, and you will get your, and you will get, let's say, you will be able to solve this kind of polynomial to the power 6. Okay, it's not difficult, but you should practice it as it is and train yourself to get advanced, okay, to get more advanced for new track examples, means for other examples where there is a track, where there is, let's say, a secret inside this kind of polynomial to the power 6. Okay, now learners, it's easy. I'm going now to use the discriminant formula of Mr. Mourad Sultan Ezouidi when k equals 0. Or when k equals 0, I'm going to see that s minus 1 of order r, in fact, is equal to what, learners? Equal combination 0 and choose 0. Okay, copy. I will make here this one, in fact, is equal to, when k equals 0, means that you are going to work with combination. I will make capital C. Combination means combination. Where is capital C? Combination. This is minus 1. I'm going to write it here, and I have to add 1. Minus 1 comes here, Mr. Murad. Of course, this is n. Okay, the highest power of my polynomial. This one is gonna be, okay, this one is gonna be minus 1 plus 1, which is equal to 0, in fact. So it will be combination and choose 0. Combination and choose 0. This one, okay, I will call this one combination, control C. So this one is equal combination. 1 minus 1, learners, is going to be very easy for you, is 0. But you can see this is n denotes the degree of my polynomial, which is 6. Okay, this one is going to be 6. So 6 choose 0, learners, is what? Is in fact equal to 1. So by convention, s minus 1 of order r is equal to 1. Okay, now I will continue. I want to find a 0, learners. To find a 0, you should substitute or set k equal 1 in the discriminant formula of Mr. Mourad Sultan Ezouidi. Okay, and this discriminant formula had been developed after 14 years of work. Okay, not only this theorem that I'm working now with, but there are so many other, let's say, worth methods. Okay, so now I'm going to find a 0 for the r. We have, learners, negative 6 choose 1 times 1, because the first coefficient, the second coefficient in front of x raised to the power 5 is 1. So 6 times 1 is minus 6, and we've got the negative sign. Plus 6 times 1 is 6, so this one is going to be 0. And a 0 for the r is the sum of the x roots, okay, which is equal to 0. Okay, this is by convention also, because n minus n is going to be 0 whatsoever the value of L0 for the cube. Now we move to S1. I'm going to find the S1, learners. I should, or you should, learners, you should substitute k equal what? K equal 2 in the discriminant formula of me. I will just write it as that, okay? I will reduce this one small so that you can see. Okay, I will reduce, okay, okay, like that, okay. So now when k equal 2 learners, just substitute k equal 2 in the decimal formula of Mr. Mourad Sultan Ezouidi, we will obtain as 1 over the r equal, the last tensor is minus 1, choose 1, of course combination, times combination n, choose 2, n is 6 here, times L0 of ODQ squared, L0 is here, that is 1 here, time plus n squared, okay, n is 6 times L1 of OD2, L1 is going to be 21 divided by 6 squared. Okay, I will apply this. I will use my calculator. You can also use your scientific calculator learners and calculate at the same time the value of S1. For solving any nth degree polynomial equation, there is no other method. Okay? Don't use the factor theorem. Okay? That you will guess, let's say, plus -1, plus -2, plus -3, plus n, and you will check if it is a root or not. Okay? So here you will just apply the formula of me and you will get your complexes with no mistakes, okay? And you will get no error of estimation. You will get exactly the root of this polynomial to the power 6. Okay, let's focus on this. So S1 is gonna -1, choose 1 is -1, times combination 6, choose 2 is 15, times 15, times 1 squared, okay, plus 6 multiply by 21 divide by 36, means the plus 21, plus 21. So this one, learners, is going to be equal to 6. Therefore, S1 here is going to be equal to 6. We proceed. We want to find now, learners, the value of S2. Okay? The value of S2, to find S2, learners, you should substitute K equal 4, okay, in the discrete formula of me, and you will get S2 of order R equal the sum from 0 to 3, combination n minus R, choose 3 minus R. N raised to the power R. The n is 6, because the highest power is 6, times minus L0 of ODQ raised to the power 3 minus R, times LR minus 1 of ODQ, equal negative combination to 3 and 0 for the q raised to the power 3 plus n times combination n minus 1 choose 2 times L0 of ODQ squared times L0 of ODQ minus combination n minus 2 choose 1 n squared times L0 of ODQ times to the power 1 times L1 of ODQ plus the cube of n times L2 of ODQ. You will just focus on the last one. After simplifying this, you will get this one. It will be combination 2 choose 1, which is 2, times combination n choose 2. L0 of all the q cubed. Why? Because here we have L0 of all the q cubed, and this one L0 of all the q squared times L0 of all the q raised to the power 1. Okay? Same base, different power, different indices. Means I will add the indices, it will be 3, so therefore this is the common factor. I will put here, it will be L0 of all the q cubed, between parentheses, the difference between n combination n minus 1 choose 2 minus combination n choose 3. This one, according to me, is going to be equal to combination 2 choose 1 times combination n choose 2. Okay? L0 of all the q raised to the power 3, as we told before, minus n choose n minus 2 choose 1 times n squared times L0 for the q times L1 plus n cubed times L2. I will just make substitution for the value of L1 and L0 and L2 from this to that, or from here to this. Okay, so we told that, of course, here in L2 is that, learners. Okay, this is the coefficient. Okay, I will make copy. I'll put them here. Okay, these are the coefficients. Okay, there is something here. Yes, okay, this one, of course, the coefficient that I'm going to work with now. Okay, now make enter, Mr. Murad. Okay, I will calculate with all the S2. So S2 is that, is combination 2 choose 1 times 6 choose 3 times 1 cubed minus 4 choose 1 6 squared times 1 raised to the power 1 times 20 divided by 36 plus 6 cubed times 44 over 260. So I will just now calculate this. We have a negative 2 times 6 choose 3 is okay, 20 times 20 times 20 times 20. Okay, minus 4 times 21, because all of this is going to be 1. So therefore minus Mr. Murad, 4 multiplied by 21, then plus 44, plus 44, because 6 cubed divided by itself is going to be 1, plus 44. This one, learners, is going to be equal to 0. Therefore, S2 equals 0. Now I'm going to find the fourth coefficient. You should substitute k equal 4 in the discrete formula of me, and then make, let's say, or expand this and try to simplify and write it in its lowest term, like that. Okay, in its least lowest form. Okay, simplest form. So this S3 is going to be equal to negative 3 choose 1 times combination n choose 4 times L0 of ODQ raised to the power 4 plus combination n minus 2 choose 2 times n squared times L0 of ODQ squared times L1 of ODQ minus combination n minus 3 choose 1 times n cubed times L0 of ODQ raised to the power 1 times L2 of ODQ plus n raised to the power 4 times L2. So this one, this last formula, okay, will give you the coefficient of the fourth coefficient of your new sixth degree polynomial equation. Okay. Now we told that learners, okay, we told that learners here we will just practice or substitute L0 with 1 and L1 with 21 divided by 6 squared, and L2 is going to be 44 by 6 cubed, and L3 is going to be 62 divided by 6 raised to the power 4. Just use your calculator. This is means I'm going to calculate this slowly. S3, this one, and try to find the value of S3. Therefore, okay, I will just now write what exactly negative 3 times 6 choose 4 is 50. So negative 3 times 50 minus 44, negative 44 times 50 plus 4 choose 2 is going to be 6 plus 6 times what? Times 21. Simply because 6 squared divided by 36 is 1. So multiply by, immediately make multiply by, we call multiply by 21, by 21. Then minus 3 multiplied by 44, minus 3 multiplied by 44. Then a plus 62. Simply because 6 raised to the power 4 divided by 6 raised to the power 4 is going to be equal to 1. So just write plus 62. Plus, learners, plus 62. This one, in fact, is equal to 11. Okay? So therefore, S3 is going to be equal to 11. Now, I'm going to find, let's say, S4. To find the S4, you don't have other method. You should substitute k equal 5 in the discrete formula of Mr. Mourad Sultan Ezouidi. Okay. 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 So I'll just go back. I will answer my family. Okay. 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 So we told that. Okay. Okay. I'll finish then I will come. Okay. So we told that now to find, let's say, the value of S4, learners, you should go to the discrete formula of Mr. Mourad Sultan Ezouidi. This is the discrete formula, my kids, is that. This is the discrete formula of Mr. Mourad Sultan Ezouidi. I will write it here. Okay. I need only this one. No need to the rest. Okay. This one is gonna be, okay, this is the discrete formula of me. Okay, when k equal 5, I will just write it here as as 5 minus 1, okay, or I will write it as k minus 1 as it is from 0 to k. Let's see the discriminant formula of Mr. Mourad Sultan Ezouidi that he had developed to find the coefficient of the new nth degree polynomial equation relative to the original nth degree polynomial equation. This is k, of course. Okay, this is of course k. So this one, learners, is going to be the discrete formula of Mourad Sultan Ezouidi that will get to find the coefficient of your new nth degree polynomial equation. Okay. Now we told that we substitute k equal 5 in this discriminant. That's why he is S4 simply because 5 minus 1. This is 5 simply because k is 5. Combination n minus r, choose 5 minus r because here k is going to be 5. N raised to the power r as it is here. Negative and 0 for the q raised to the power k minus r. K is going to be 5. That's why it's written here 5 minus r times lr minus 1 over the q. After simplifying this, learners, we wrote it in its simplest form. In its simplest form is going to be is meant by writing S4 for the R equal combination for choose 1 times combination n choose 5 times L0 for the q raised to the power 5 minus combination n minus 2 choose 2, 3 n squared times L0 for the q cubed times L1 of the q plus combination n minus 3 choose 2 times n cubed times L0 for the q squared times L2 minus combination n minus 4 choose 1 n raised to the power 4 times L0 for the q raised to the power 1 times L3 plus n raised to the power 5, okay, times L4 of 4. Okay, now I will use my calculator, learners, and you are going to work at the same time with Mr. Mourad Sultan Ezouidi so that you can find the value of S4. Okay, I will use my calculator. This is S4, learners. This is S4. Okay, I will means I'm going to calculate only this after substituting, let's say L0 with 1, L1 with 21 divided by 6 squared, and so on. Okay, we just make substitution. Now I will just work this. I will go back. I have here what exactly? 4 choose times 6. Okay, I will make 4 multiplied by 6. Multiply by 6. Great. Minus 4, minus 4, minus 4, multiply by 21. Multiply by 21. Plus 3, plus 3, multiply by 44. Multiply by 44. Minus 2, minus 2, multiply by 62. 62. Then plus 52. Plus 52. This one, learners, 52. This one, learners, is going to be equal to 0. Therefore, S4 here is equal to 0. Okay? Now I'm going to proceed. I should continue. I will make a jump. I want to find the last part, which is S5. When you reach S5, meaning that you rearrange your new 6th degree polynomial equation and write it as x raised to the power 6 minus S0 of order R or Q x5 plus S1 of order Q x4 minus S2 of order Q x3 plus plus S3 of order Q x squared minus S4 of order qx plus S5 of order q. Okay, you can see that all the coefficient subscript odd numbers are positive. Okay, and the other also we should put negative sign. So now I will put k equal 6 in the discrete formula of Mourad Sultan Ezouidi, the Tunisian researcher in mathematics. Sorry. So I will write S5 equal from the sum from 0 to 6, combination n minus r. N is 6 in fact. 6 minus r, and 6 minus r will be 1. n raised to the power r between parentheses negative 0 of ODQ raised to the power 6 minus r times LR minus 1 of ODQ. This one will give you the fifth coefficient, the sixth coefficient of any nth degree polynomial equation. Okay, so these steps are very important for you, and you cannot work out or find, let's say, the polynomial to the power n that corresponds to the roots of another polynomial to the power n. Okay, so you should follow this formula to get the coefficient of your new nth degree polynomial equation. Okay, this formula has been generalized, and we, as Mourad Sultan Ezouidi, we worked on this kind of example, and we invented this or discovered this after, of course, 14 of years of work, 14 years of work, okay, and of concentration and of practice. And okay, we got this point. Okay, we got, let's say, this light. Okay, seems like a light. Okay, something that light your way, light your room, light your area where you are settling. Okay, where you are settling. Okay, so I'll just write as 5 as, after simplifying learners, I will just focus on the last one. Is 5 equal minus 5 choose 1 means combination, and 0 of 6 and 0 of ODQ raised to the power 6 plus n squared and 0 of ODQ raised to the power 4 times and 1 of ODQ minus n cubed times n 0 of ODQ raised to the power 3 times n 2 of ODQ plus n raised to the power 4 times n 0 of ODQ squared times L3 of 42 minus n raised to the power 5 L0 of 42 raised to the power 3 times L4 of 42 plus n raised to the power 6 times L5 of 42. Now I'm going to apply my formula, and I will calculate this. You see this one? This is L5, I put here. This is L4, I'm going to put here. This is L3, I put it here. This is L4, L2, I put L2 here. And this is L1 of ODQ, I put it here. And this is L1, it's written here. Okay, using what? The discrete formula of Mourad Sultan Ezouidi when k equals 6. And after, and using the last, or the last that had been simplified or written in its simplest form. Okay, where you can simplify, you start to simplify because there is no common terms or like terms you are going to add or subtract. Okay, so all of this is written in its simplest form. Okay, now I will calculate this. So we have, I'll put this up so you can see. Okay, I will erase this one. So we have learners as 5 equal negative combination 5 choose 1 times 1 raised to the power 6 plus 6 squared times 1 raised to the power 4 multiplied by 21 divided by 6 squared minus 6 cubed times 1 cubed times 44 divided by 6 cubed plus 6 raised to the power 4 times 1 squared times 62 divided by 6 to the power 4 minus 6 raised to the power 5 times 1 raised to the power 1 times 52 divided by 6 raised to the power 5 plus 6 raised to the power 5 multiplied by 21 divided by 6 raised to the power 6. You can see that this one is 1, this one is 1, this one is 1, this one is equal to 1, and this one is equal to 1. Why? Simply because 6 squared divided by 6 squared is 1. 6 cubed divided by 6 cubed is 1. 6 raised to the power 4 divided by 6 raised to the power 4 is 1. 6 raised to the power 5 divided by 6 raised to the power 5 also is 1. And 6 raised to the power 6 divided by itself is 1. So I'm going to focus on the last numbers between parentheses. I put here, okay, between parentheses. I'm going to use it immediately. Automatically, I will automatically means automatically. Automatically. Can say automatically or automatically. I prefer pronouncing it as automatically. 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 Okay? Not remark in French. No. Automatically. Automatically. Okay. You got the point. How we pronounce it. Good man. Good boy. Okay. So I will use my calculator. Okay, we have negative 5 plus 21 minus 44 plus 62 minus 52 plus 24. So just start minus 5 plus 21 plus 21. Okay, again plus 21 minus 44 minus 44. Okay, plus 62 plus 62 minus 52 minus 50 plus 24 plus 24. So this one, learners, is going to be equal to plus 24 is going to be equal to, okay, to 6. Just again, we have negative 5 plus plus 21 minus 44 plus 62 minus 52. Okay, plus 24. This one is equal, Mr. Murad, a 6, equal 6. Okay, so this one is equal 6. Let's see again. Negative 5. This is negative 5. Plus 21. Plus 21. Minus 44. Minus 44. Plus 62. Plus 62. This is 62. Then minus 52. Minus 52. Then plus 24. Plus 24. Equal 6. Okay, so now I get my coefficient of my new 6-degree polynomial equation. Now I will rearrange the coefficient and rewrite again the new polynomial, and I will focus on the coefficient of it. We can see that, in other words, S0 is going to be 0, S2 is going to be 0, S4 is equal to 0. So equal to 0, right? Not equal. Okay, equal to 0, of course. I will erase this, equal 0, equal 0. Okay, erase this. Okay, except S1 of order R is 6. S3 of order R is going to be 11, and S5 of order R equals 6. Now I'm going to write my equation. The equation, we told that this one, P of x, after finding the new coefficient, has to be written as P of x equal x raised to the power 6 minus S0 of order R raised to the power R, x times raised to the power 5, plus S1 of order R, x raised to the power 4, minus S2 of order R, x raised to the power 3, plus S3 of order R, x raised to the power 2, minus S4 of order R, times x plus S5 of order R equals 0. Now this one, I will put x squared equal y. And this one is going to be 0, no need to write it. This is 0, also no need to write, and this one. So it remains, I will get to the power 6, okay? Has to be written as x raised to the power 6 plus 6x raised to the power 4 plus 11x squared plus 6 equals 0. Let x squared equal y. Now I will get to the power 3 in terms of y. P of y equal y cubed plus 6y squared plus 11y plus 6 equals 0. Therefore, the roots of this polynomial to the power 3 is going to be y equal negative 1, and y equal negative 2, and y equal negative 3. Therefore, if y equal x squared, therefore xk is going to be equal to plus negative root of minus 1 is going to be plus negative I, imaginary complex number, or plus negative root of 2i, because this one is negative, or plus negative root of 3i. Therefore, to make conclusion, I can write now the roots of my new polynomial to the power 6 that I started with. In fact, is A0 for the cube plus x roots plus x subscript k from 0 to 5 roots. Okay, all divide by 6 because the highest power is 6. It will be 1 because A0 of order q is 1. 1 plus negative I, simply because this one, divide by 6, or 1 plus negative root of 2i divide by 6, or 1 minus root of 3i divide by 6. Okay, so all the roots now are complex numbers. Thank you for listening, and see you next time. This is the pioneer method Tunisian. Okay, you search the he defy, let's say, the context of no, we cannot do it. No, we can do it, and we can prove, and we can, let's say, discover and do whatsoever. Okay. So thank you for listening. This is our polynomial to the power 6. I'm going now to go to chat GPT, and I will tell him, please solve this. I see, yeah. I will do this now with our view. Okay. So the roots now, it's clear. That's 1 plus negative I, okay, divided by 6, or 1 plus negative root of 2I divided by 6, or 1 plus negative root of 3I over 6. Okay. What happened here? Go step by step. This is now the polynomial. As we finish it now, I will give this to ChatGPT, okay, and see what we can do. Okay, I will turn it like that. Okay, thank you, of course, of listening, and it's a new occasion learners for you to get to know about polynomial to the power 6, also where the real number, where there is no real numbers. Okay, clear. Okay, I will make first. Okay, save this. Now I'm comes here, learners. Now you can, okay, now we solve the polynomial to the power 6. I'm going here to make chat GPT. Chat GPT. Okay, please solve. Okay, okay. Normally thought that he can do it if he has my method, okay, or using, let's say, graphic or something like that. But the roots are given by approximation. They approximate, let's say, the answers, but they didn't give you exact value. But my theorem, my method will give you exact roots. There is no estimation. Okay, solve please. Solve please. Okay. Could you please provide me more details? Okay, this is the details. Okay. Okay, he will write. Okay, 6. Okay. What is that? Okay, why he wrote? Okay. I will take it as it is. This is x raised to the power 6, of course. Okay. This is the other. I will take as it is. Okay. I wrote something, then I wrote something. Okay. Now this one. Yeah, that's it. Okay, x2. Yeah, that's equal. You see here. Okay, I will write now again. Okay, no problem. I will write this here. Look, this is p of x equal. I will write, okay, I will write this. Okay, I'll put it here now. So I'll just write p of x equal p of x. Here. P of x equal x raised to the power equal x scenario equal x. I change this one. Of course, this is 6. This is x. Okay. Then minus, now take this. Minus, I will make 5. I will write again, okay, no problem. Plus 21 divided by 6 squared, x4, then minus, of course, minus L2, which is equal to 44 divided by, I will make here x3, x3, okay, then plus, and 3 is going to be equal to 262, of course, divide by 6 raised to the power 4. I will make x squared. I will raise 6 here, make 2. Then the last one, minus this one, 52 divide by 6 raised to the power, okay, to the power 5x minus or plus, of course. Okay, I will erase this one. So this is the equation. Okay, of course, equation. Okay, this is the equation now. I will give to it now. I rearrange it. Why he wrote it with other? Because this one is done separately. This x into the power 6. If it is an equation like that, okay, in one rectangle, so maybe it will be acceptable for him to work. So this one, okay, what's this? Okay, here I thought I will take this one, only this, copy. Now I come in like that. All now the roots, in fact, are complex numbers. Okay, this is ChatGPT. He wrote it now. Okay, okay, okay. Do your best. Do your best. You see, you see. Okay, solve the equation. At this point, solving polynomial equation algebraically is complex because it's the sixth degree polynomial equation. It might be solved numerically, or you can attempt factoring if possible, if it is possible, or use a numerical method like Newton method and so on. So you would like to proceed? Okay, this is the answer that he gave are false because this polynomial has complex roots. There is no real root. You see? Okay. Step simplifying the coefficient. Now let's say it's a fraction. Okay. So he did nothing. He did nothing. He just write this polynomial in different way, simplified something maybe in common. Okay, for example, 21 divided by 6 squared. There is a 3, it will be 7 divided by something, okay, by 18. So he did nothing, and he told that I can't do it, in fact, because the highest power is 6. Okay, I will tell him, okay, continue, solve, continue. I want you to find. I want you to find the roots. The roots. Okay. Continue. To find the roots of this polynomial numerical method, the Newton method, or other. Okay. So this polynomial to the power 6 is finding the exact roots analytically might be difficult. Might be difficult. Okay. However, we can use the numerical method to approximate the roots. Method of Newton. Okay. So and he can't apply method of Newton. I will tell him, hey, take my method, take my method, and I will give you, and I will give you the roots. Okay, what do you think? Exact roots, I mean. Exact roots, I mean using my theorem. So I have specific method you would like to use for roots. Feel free to share it. Okay. I will give him now the roots and I will tell him go to check. Okay. Where is the roots? Where are the roots? Sorry. These are the roots. Okay, these are the roots. This one are the roots. Okay, I'll make copy. Okay. Okay, comes here. You see, he didn't get these are the roots. Okay. You will write this again. It looks like you are trying to apply specific method or theorem of finding the exact roots of polynomial. But I need more clarification to properly interpret the theorem you are using. Okay, from your notation, it appears that you are considering complex roots of the form. Okay, but in what he told, okay, this is he can do nothing in fact. So now I will go back to go to solver, math solver, math, math solver, math way solver. Let's see what he can do. Okay, let's see this one maybe, yes. Okay, I will give him now the the exercise. Okay, this website will use graphics. Maybe he will find the solution because he's using graphics. Okay, for each special point he has to graph it and see where they can access. Okay, and they will do the approximation. Okay, now I will give him this one. Yes, this one, and I will see what can he do. Copy and paste. Okay, solve. I will tell him solve. Okay, what he wrote, he stopped doing anything. Okay, he stopped doing anything. Now he will try. You see, he just make graphics. Okay, now I will see if he can solve one. You see, he did nothing. He did nothing. He tell me, thank you, Mr. Murad, for this example, but I'm really unable to solve it. Thank you and goodbye. Let's see the pioneer, the Tunisian in math, Mr. Mourad Sultan Ezouidi. Okay, and the graph of this is false simply because it cuts the x-axis, and we told there is no real roots. Okay, even this curve is false. Okay, clear. Thank you and goodbye. Okay, this is Mourad Sultan Ezouidi, the pioneers in methods. Thank you and goodbye. Okay, I will now